On page 7. Oh yeah, there's a slight error in that one. I don't know if that was wrong. This should be a comma. But was that your question, or did you have a different question?
I just have to
Question on how to do this one. Yeah, you're asking about concentration. You gotta write the Nernst equation out. Write it out. So there's that one. Q, product silver reactant. So Q. Did I write that? I don't know if I got the Q exactly right. Hopefully, you have to write out the whole reaction. You have to write this is this being reduced, Cu2 plus 2 electrons goes to copper. You have to add it to this being oxidized, which would be iron 2 plus goes to iron 3 plus plus an electron. You add them up, you put the products on the top, reactants on the bottom. I think I got it here. I kind of did it in my head, but if it's a test, I'd actually write it out. Oh, is there 2 of them? Yeah, because there's 2 electrons. Both irons would be squared. Thanks. So I'm just trying to do it fast so you get to a lot of questions. But what you want to do now, the only thing that's changing is Q. So then, if Q increases, is that going to cause E to go up or down? And then if Q decreases, it would be the opposite. So you kind of want to do that mathematics in your head. If you can't do it like with a natural log, I forgot what the natural log is or whatever, then just pick a random number, natural log of 2, and then you see if it goes up or down. Then try 4, because you just increased it. So you can pick a random number. So half this, that's making Q larger, right? This is making Q smaller. This is making Q smaller. This is making Q, it looks kind of fuzzy, but the 2's on the bottom, smaller. Now I can't read if that says 2 or 3. But 2, so smaller. Oh, well, there's only one making it larger. That's probably, if I'm gaming the test, that's probably the answer. But you want to say if Q gets larger, does E go up or down? If Q gets smaller, does E go up or down? And then pick the one that matches what you discovered. Is that okay? Is that too vague? Okay. Let me kind of just make sure I get through a bunch of questions. Someone over here? No? Yes?
So for the nomenclature quiz, you said there were some that were different than on OWL, but my TA had no idea what handout that was.
He was at the TA meeting. Okay, I don't know. I gave a little list at the TA meeting when we met. I don't have it on me right now, though, unfortunately. You might be able to ask a buddy from another section, or make friends, or you have to ask me later. Yeah. It's like nitro. Nitrido is nitro. There's a couple of them. There's only 4. Oh, make friends over here. Yes. Just like how do you know what goes on top and bottom? M2A, you got to write, or 2B, I mean, you got to write out the reaction. This is a reduction. And the other one's an oxidation, because it's an anode. Now you add them. And then you remember in 2B where you put products over reactants? That stuff. Is that okay? Okay, good. Yes? Same thing as what they just asked. Yeah, not the same question, same concept. You don't have to be embarrassed. Same concept. This is called a concentration cell, when it's the same thing on each side, just like you did in lab for like part 2 or 3 of Electrochem lab. So, this is the discussion worksheet. So, how do you know what's on top or bottom? You write this out. So you got to write the reaction out. So for the left-hand side, it was number 3, this one? For the left-hand side, that's an oxidation. So write it as oxidation. Does that look good for an oxidation? This is the one where this has the 0.1 concentration. And then now the other side is the reduction. And this is the one that has a 0.85. Now you add these up. It looks like this one's going to be in the product, so it'll be in the numerator. Is that okay? Yeah, that's it. So same idea as what they were asking over here. How do you know it goes on top and bottom? You got to write out the reaction. Even if you do it in your head, it's good to double check by writing it out. Yes?
Is E standard always 0 if you have concentration?
Great question. Is E standard always 0 when you have a concentration cell? Yes. Okay. Yes. Okay, this is a worksheet question from the discussion. Structures of 4 complex ions are given. These 4, each has CO3+. The ligands are those, which is true. Determine which, if any, of these complex ions are isomers, whether geometric or optical. Which, if any, are identical. Yep. Yeah. So, for example, yeah, these two here. Yeah, see how the OH here is trans and on the right is cis? And the NH3 is trans here and cis here? That's a geometric. Is that okay? Etc. Now this is a fact, so it's totally crazy different. These are cis trans, it doesn't apply to any of them. This one, now you got to compare to this one, they are mirror images as drawn. Are they the same or different? Can anybody tell? Same or different?
Different.
They are the same. You see the trans. That's the hint also. So they're identical. So A and B are identical. That kind of stuff is what it's asking for. Okay, next. I would want to see anybody else? No? Okay, yes. We'll give everybody a turn. Yeah.
Would you read the 7 on
Page 7, number 13. This one right here. All right, this is the electrolysis calculation, just conversion, okay? Here, though, they gave you molarity. So you have not grams to moles, but molarity to moles. That's it. That's the only difference. So, this is fall 2016. Zoom out. Coulomb is amp per second. Usually you multiply this by the time, which is did they give the time? Oh. Okay. Oh, cool. Nice. Okay, let me write this out. 0.250 moles per liter. Let's go for the moles first and then go from there. Times 600 milliliters. You gotta go 1 liter per 1,000 milliliters. Okay, now you're gonna have the moles. Is that all right for the moles? Okay. Then let's see what else we're gonna have. We know that this is the moles. Let me write the reaction. I'll just write as a reduction. It won't matter for what we're up to. For every 1 silver, there's 1 electron. Is that cool? For every 1 silver, there's 1 electron. So, let's see. This is for okay, because this is moles of silver technically right here. Is that cool? Now we're moles of electron, and now we know there's 96,485 coulombs per mole of electron. It's the same time calculation, it just was one step less because they didn't need the time. To do the time, yeah, I got this mixed up here. To do the time, that's if you want to get to the current. But because they just started coulombs, you made one step less. All right.
Can you?
They wanted coulombs. That's right. They didn't need the amp, so you don't need the time. Yes?
Can you do the question below that one?
Okay.
On the test, how do you get 5 times 10 to
14?
the 106? Yeah.
How do you get this?
Yeah.
Did you know, were you unsure how to set it up?
I got C for the answer and it was wrong.
Oh, that's unfortunate. Okay. Better now than on the test, right? So, you need to first find the half reactions. Okay? So, you've got a magnesium going to magnesium 2 plus. Forget the nitrates. Do you know why you can ignore the nitrates? They're spectator ions. If you're on both sides, they don't oxidize or reduce. They do nothing. So then for the other part, you've got, looks like silver going to silver solid. So if I balance it, there's 1 electron in there. Now, I gotta look this up on I need the E standards. I look it up on the table in the back of the test. Is that all right?
Mm-hmm.
Then I add them. And this will give me the E for the entire cell. And then I say delta G. Oh, no, not that one. It's K. What's that formula? E equals minus 0.256 over N natural log of K. I think that's it.
Mm-hmm.
That number goes here. What's N, anybody?
2.
2, because that's the number of electrons that'll cancel. Is that okay? Do you do the math from there?
I did do the math from there, and that's where I was. Like I did all this correctly. I don't know how.
Yeah, show me on your calculator then.
Okay.
Yeah, maybe on. When I walk, you can walk back with me and show me what your calculator did.
Okay.
Cue it up for me. Okay, let's do a last question. Or no question. Oh, yes. This is a worksheet question. Of the following, which are identical, which are geometric, which are same question as before. So you're just kind of giving a bunch of like mix and match and figure out what's what. You compare them all to each other, yeah. So for example, let's see if we can find any that are similar. These two might be similar. See how there's 2 bidentates and a cis. So they're either identical or mirror images. Are identical or mirror images that are the same or mirror images that are different. So just that's something to ponder. This is trans. And let's see, here's another trans. See it? Okay, those two would be trans with 2 bidentates. Identical. Or trans, the mirror, it's going to be the same. If you just flip it around, you'll see. This is another cis, so now you got to compare these 3 fools.
You only compare what's trans and trans?
Well, you could say, well, these are geometric isomers, cis and trans. So are these, so are these, so are these, so are these. The trans to the other trans could be identical. But the cis to the cis, one of these 3 might be a mirror image that's different to another one. With all the same ligands given, I mean, not always, there are examples, trans with 2 bidentates, yes, but like if these ligands were different, you know, if they're not 2 bidentates that are identical, no, not necessarily. But you can rotate it in space if you don't believe me. And check it out, you'll find they're the same. Okay? So they're just wanting to compare. It's a way of asking the question to have, instead of you drawing and do that identification, you just identify. Oh, which ones are you supposed to compare to? All and everything. All right, how was today, okay? Okay, hope it was helpful. Our sub will do some review questions as well. But you can also look at YouTube for the stuff I've posted already.